Welcome, ladies and gentlemen, to the last lesson of our oblique triangles. In this lesson, we're going to determine the area of oblique triangles. We can't just use 1/2 the base times the height because we typically don't know what the actual height is, or that perpendicular distance from one vertex to the base of the triangle. So we've got two new formulas, and then we also have a couple of review of the applications that we've done just to kind of keep it fresh. All right, so the two different ways that we can find the area of oblique triangles are one, which is the oblique triangles area formula, and two, using Heron's formula. We use the area of the oblique triangle formula when we are given two sides and the included angle. So when our triangles have some sass, side angle side. And these formulas are all interchangeable depending on the two side lengths and the included angle you're given. The examples we're going to practice actually don't have any of the sides listed, but I do show you how they are all interchangeable, and I use each of them so you can see that it doesn't matter. So our area formula is 1/2 of the product of the two side lengths, B and C, multiplied by sine of the included angle, which would be sine of angle A, or 1/2 AC multiplied by sine of B. And lastly, 1/2 AB multiplied by sine of C. Okay, so here's our first example, and we're going to check. Do we have some sass? Yep, we do. We have a side angle side. We don't have side, side, side. That's our next that we're going to do. So we're given side 8, side 3, and the included angle 84. I know this looks like a right triangle, but you have to go by what you are given. So we're going to do 1/2 AB multiplied by sine of angle C. Substitute in 1/2 multiplied by 8 multiplied by 3 multiplied by sine of 84, 100%. Type it straight into your calculator. Make sure that your mode is in degrees. And when you round to the hundredths place, you'll have 11.93 units squared. They didn't tell us if they were feet or centimeters, so we just need to write units, or U for units, and then square it because it is for area. In this next example, our triangle has a side length of 17, an included angle of 49 degrees, and another side length of 8. So we do have some sass, a side angle side. We're going to use 1/2 BC multiplied by sine of A. Again, not labeled, but you can call them whatever you want as long as you know which ones are the sides, the lowercase, and which ones are the angles, the uppercase, or the ones inside your triangle. So we're going to write 1/2 of 8 multiplied by 17 multiplied by sine of 49 degrees. And in your calculator, rounded to the hundredths place is 51.32 units squared. Piece of cake. These go so fast. All right, in our last example of a sass, side angle side. Oh, the answer's already popped up. So see if you can write it down. We have a side, included angle side. It doesn't matter if these are A and B, B and C, or A and C. Okay, I chose 1/2 AC sine of angle B. 1/2 of the product of 9 and 7 multiplied by sine of 134 degrees gives us 22.659, so rounding to the hundredths gives us 22.66 units squared. Good job. So each of those triangles uses the regular formula for area of oblique triangles, 1/2 product of the sides multiplied by sine of the included angle. That's when we have some sass. The next set is Heron's formula. We use Heron's formula when we have the three side lengths of the triangle given. Now, could you go back and use law of cosines to find an included angle? Sure, but why would we do that if we can just use this formula? If you'll notice, it has the square root, and it's got product of sides along with an S value. And so some of that kind of comes from deriving some of the other formulas, law of cosines. So the area using Heron's formula is S multiplied by S minus A, the product of S minus B and S minus C, and you take the square root of that value. S is the sum of the three sides divided by 2. And you always have to determine the S value first. It's okay if it's a decimal, not a big deal. You'll just put a decimal in for the S, substitute in. All right, let's try a couple. First one, do we have side angle side or side side side? We do have 3 sides, 8, 14, and 10. So we are going to use the sum of the sides, a plus b plus c divided by 2. So 8 plus 14 plus 10 divided by 2 will give us 16. That is our S value. We substitute this value into our equation for the area, the square root of S, multiplied by S minus each of those sides individually. You can simplify them or just write them as the square root of 16 multiplied by the product of 16 minus 14 multiplied by the product of 16 minus 8, and then multiplied by the product of 16 minus 10, which would be 16 multiplied by 2, multiplied by 8, and multiplied by 6. You can type it straight in just like it is. Rounding to the hundredths place, we get an area of 39.19 units squared. Again, units of measure weren't given, so we put the U or the word units. And it is area, so it has to be squared. And our final example, we do not have any SAS. We don't have an included angle. We have all 3 sides, side, 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 with lengths 7, 4, and 5. So we are going to find the sum of the sides and divide by 2. 7 plus 4 plus 5 is 16, divided by 2 gives us 8 for that S value. We will then substitute that into our formula. The area equals the square root of S, multiplied by the product of S minus A, the product of S minus B, and the product of S minus C. So we'll substitute in the area equals the square root of 8 multiplied by 8 minus 7, multiplied by 8 minus 4, and 8 minus 5, or 8 multiplied by 1, multiplied by 4, multiplied by 3, and then take the square root. And you guys, when you type this into your calculator, if you're using the scientific ones, it gives us 4 square root 6. So you got to change that into decimal form, 9.797, and I just rounded this one to the tenths place, because when we round up to the hundredths, it rounds again. So we get 9.8 units squared. Great job. That is the last topic that is new for area of oblique triangles that we're going through in this unit. We do have a couple of application problems just as quick review, and we got some time, so here we go. A tree leans 7 degrees to the vertical. Okay, we'll think on that for a second. At a point 40 feet from the tree, on the side closest to the lean, the angle of elevation to the top of the tree is 24 degrees. Find the height of the tree. We kind of got a lot of stuff we got to process here. So our tree is leaning. It's not vertical at 90 degrees. It's leaning 7 degrees off of that. From that point, 40 feet over to the other side of the tree, so 40 feet away from it, at that distance across, then we have an angle of elevation looking up to the top of the tree. All right, so let's get some pictures. There's my vertical with the ground. My lean is 7 degrees. Okay, so I have a teeny little lean towards the tree. This one is very specific to the vertical. It's leaning towards that. Okay, here is another side length that we would use to create from the top of the tree to the other side where we are 40 feet from. All right, so back to this angle. If we're leaning 7 degrees towards the vertical, I already have 90 degrees over here, so I'm adding another 7 to it. So that exterior angle from the ground to that side of the tree right here is 97 degrees. That means the interior angle would be 83, or 90 minus 7 degrees. So outside the triangle gives us 97. That's kind of like our turn. And inside is the 83 degrees. Now, again, we're 40 feet away from the base of the tree. And on this other side, our angle of elevation up to the top is 24 degrees. Okay, so we got to think about that for a minute, process it, make sure you got it going the right way. Okay. What are some other things we need? We need to find the height of the tree. That's going to be the distance that I have, that little shade that's in brown. It's also probably going to be important for us to determine the angle at the top, where the tree and the other side looking up equals. So that's 180 minus the 2 angle measures, the 24 angle of elevation and 83 from the lean of the tree, and that gives us 73 degrees up here at the top of the tree. This is a side angle side example, we have some SAS. Not for the area, we're just looking for side angle side to use law of sines in order to solve. So we did need that angle across from the distance from the base of the tree to the other side. We needed that 73 degrees across from 40 feet. Okay, so the height of our tree is going to be x. So x over sine of 24, that is the angle across from where our tree is, equals 40 over sine of 73. That's this distance on the ground and that angle. Cross multiply, isolate x, and in your calculator you can type in the ratio 40 sine of 24 divided by sine of 73, and that gives us about 17.01 feet. Good job. Now, again, this example was specific, leans to the vertical. If we did not have that specific direction of the lean, we would have had to have solved this the other direction as well, leaning away from the vertical. It would have given us a different angle measure at the top, and the height of the tree would have been different as well. Okay, I think it would be about 19 feet, give or take. Okay, so just kind of keep that in mind. Look for those specifics. Is it leaning a certain direction? Good. All right, let's try a couple more. We have two markers, A and B, on the same side of a river and are 58 feet apart. A third marker is located across the river at point C. A surveyor determines the angle of CAB is 68 degrees and angle ABC is 52 degrees. What's the distance between A, one side of the river, across to C, the other one? All right, so let's get ourselves our picture. There's our river. We got points A and B, 58 feet apart. Cool. We have point C somewhere across the river, and we want to know what is the distance from A to C. Okay. They also tell us that angle CAB is 68 degrees. Cool. Got it. And then angle ABC, so I need side BC, angle ABC is 52 degrees. Fabulous. Cool. This is an angle side angle situation. We are definitely going to use law of sines for sure. And in this case, we're solving for side AC, that's segment, or side B. Cool. Here we go. Use law of sines. So B over sine of B will equal C over sine of angle C. I don't have sine angle C, darn. Okay, so that's easy. It's 180 minus 52 minus 68. Cool. We get the measure of angle C is 60 degrees. Fabulous. Now we can substitute that back in our formula. Side B over sine of 52 degrees is side C, 58 over sine of 60. Cross multiply and isolate your B. In your calculator, you're going to type in 58 multiplied by sine of 52 degrees divided by sine of 60. And we determine 52.775 is our distance from point A to point C. Therefore, we're about 52 point, oh, there's a typo. That is supposed to be that B is supposed to be a C. Darn it. Okay, so side B, or the distance from A to C, is 52.78 feet. Sorry about that typo. Okay, we have another question with this exam information. So now we want to know the distance across the river. Now you'll notice I've put all of that same stuff back in, and I do have a little X over here. That's for something else. It just got kind of misplaced at the moment. So across the river, that means we want the most direct route, and we want to be perpendicular. Okay, so I'm going to draw a perpendicular from angle C down to the side where the 2 points are across from the river. That's going to be my perpendicular. Therefore, I create right angles. Okay, good deal. You'll notice I also tucked in that the length of side B was 52.78. I put that back in there for us. All right, now we want to know what is that distance across the river. That technically it's the height of your triangle. So here's our picture that we're looking at. The little X that I have at the top, I need to know what that measure of that angle is so that I can solve for D. All right, now here's why. I have 68 degrees across from D. I have 90 degrees where it's perpendicular across from 52.78. Oh wait, I don't need the x. That's okay. You could still solve for it if you want to. 22 degrees. 180 minus 90 minus 68 gives us 22. So you could solve for that if you'd like to. Okay, so solving for the height of our triangle, that distance across, d over sine of 68 equals 52.78 divided by sine of 90 degrees. Again, we had perpendicular 90-degree angle. So cross multiply, and in your calculator you will type 52.78 multiplied by sine of 68 degrees divided by sine of 90. Hey, sine of 90 is 1. Don't forget that. Unit circle. All right. So the distance across is 48.937 or about 48.94 feet. Fabulous. And we are all done, guys. Make sure that you are practicing all of this. You got your law of sines memorized and down pat, law of cosines down pat. Work on those area problems we did earlier. And that's it for our unit. Thanks so much. If you have any questions, let me know.